What course do you take?
So I think we're going to go ahead and get started. Thanks everyone for coming today to the workshop on sharing your research through StoryMap. This is part of the Data and Computational Science series, so it's sponsored by the Provost Office, and we're very grateful to them for giving us funding to do this. We have with us today Joshua, and I'm going to try to make that I don't mess up the last name, Sadvari from OSU. Joshua is the GIS specialist at OSU, and in his role there, he is responsible for facilitating workshops and educational opportunities to support the use of GIS in research and teaching, and acting as a project consultant for faculty, staff, and students in all disciplines who are interested in working with geospatial data, methods, and tools. And he's going to give us the tour through StoryMap and web mapping in the beginning. Then we're going to have lunch from 12 to about 12:30, 40, and then at 1 o'clock we'll start the hands-on part of it. Okay.
Hi everybody. As Amy said, my name is Josh Sadvari. Thanks to Amy and to the UC Libraries for bringing me here. I'm looking forward to talking with you all, learning a little bit more about what you're doing, and tell you a little bit about how you might be able to use story maps in your own work. The first part is going to be sort of just an introductory presentation. I've called it Web Mapping 101, where I'll introduce you a little bit to some of the concepts and tools, and then in the afternoon we'll do all the hands-on stuff. If you want to follow along and click on any of the links for the example tools or maps that I have put in the presentation, you can go to this link, go.osu.edu/UC workshop. There's a copy of the slides in there for your reference. There's a copy of a handout with some more resources, so if you want to follow along and check out any of that stuff, feel free. Let me just start by asking the group, has anyone here constructed a web map before? A couple of people. How about using GIS in any capacity? Desktop work, so a little bit more of that. Good. I mean, this is going to be kind of basic, so hopefully this helps and you learn something new. Just a little bit about me to start. My background is originally as a researcher in anthropology and geographic information science for the last 4 years. And so I graduated from Ohio State, and for the last 4 years I've been a staff member with the Ohio State University Libraries, where I manage our Research Commons, which is sort of a research center for faculty and graduate students, and also as the GIS specialist. And so as the GIS specialist, I provide research consultations and work on projects. I teach workshops like we're going to go through today. Just in general, try to promote the use of GIS in research and teaching across disciplines. So I hope that as you learn more about story maps in particular, you'll start to think about applications to your own work, whether you're a researcher or an instructor. I help people find GIS data that they might need to use for their research, and I connect researchers with other GIS resources at Ohio State and beyond. And so my contact information is on some of the materials. If you want to contact me after the workshop with any questions, I'm happy to chat with you. Just to give you a sense of what I hope to cover in the next hour, I hope that after this presentation you'll be able to do the following things. So describe different types of web maps and understand the elements that are usually going to be included when you're creating a web map. Differentiate between different approaches that you might be able to use when creating a web map, from a fairly basic approach to sort of complex development from the ground up. And then really think about this in the context of your own work. So given what we talk about, think about what approach might be most suitable for you, what potential tools you might want to explore more in the future to make your own web maps. Before we start, I should just answer this question: what is a web map? And so, in the simplest sense, a web map is a map that is accessed on the web and also generally powered by the web. So there's a difference here between just having a digital map, which many of you may have already worked with in a desktop computing environment using something like ArcGIS or QGIS, and actually having a map be accessible on the web and powered by web technologies. And we'll go through what those technologies are as we get further into the presentation. And so at the heart of it, the use of a web map involves client-server interactions generally through a web browser, but also through applications potentially on your mobile device. So whether you're the client or the creator, that's sort of the relationship that we're going to talk more about throughout the presentation. And so this is just an example on the screen. At Ohio State, we have what's called GIS maps at OSU, and so this is our campus. So all of our administrative and planning data is publicly accessible to OSU researchers and researchers elsewhere to actually log on, explore amenities across campus, to download these data as in GIS-ready formats, and to use them in their own work. Thinking about what types of web maps exist, there are a couple of sort of dichotomies to be made. The idea of a static web map versus a dynamic web map. A static web map being something that loads and sort of stays on the page and doesn't change, where a dynamic web map might change every time you reload the page or as you pan and zoom around the page. The map on the screen is updating dynamically depending on what you're doing as a user. The second dichotomy is sort of this view only versus interactive. So is it something that you load the page and you can take a look at it and gather information from it, but not, if you click on it, nothing happens, to interactive, where you're able to pan and zoom around the map. You can click on elements and potentially find out more information. So if I click on the state of Ohio, a pop-up box might come up that tells me what's the population of Ohio, what's Ohio's largest city, things like that. And then depending on the kind of functionality that you might desire or encounter as you're kind of exploring the web map environment, here are just a few of the potential types that exist, and I'll give you some examples of these as we go. There are broad categories of online atlases, web maps that allow you to perform analytical functions, animated web maps that update with real-time information, and then also collaborative web maps. So we'll take a look at examples of each of these moving forward. This is an example that includes both static and dynamic elements. This is from the U.S. Geological Survey TopoView app. And so this is an app where basically the USGS is digitizing its collections of historical topographic maps, and you can use this as an interface to find and download those maps. So in this case, the dynamic elements are my ability to come over here and click on Cincinnati, and a marker shows up on the map, and I get to see what the boundary is of some of the USGS maps in their collection. And on the right-hand side, I have this interactive element that tells me I can click on this map and see West Cincinnati topographic map in 1914. I've clicked on 1953. It pulls up a preview for me, and I can say I want to download a PDF copy of this map. And when I click on the PDF, it opens in a new window what I would call a static map. This is a digitized version of that originally paper map. So I have the dynamic elements here that allow me to move around the map, choose my location, the interactivity of picking the specific map that I want to look at, and then in a new browser, a digitized version pops up, and the most I can do with that is kind of zoom in at two different levels. It's really just an online version of a paper map. This is a really good example of an online atlas. This is the Atlas of Canada, and if you can see, there are descriptions of different categories of maps that you can actually access here. They have buckets of interactive maps, reference maps, their digitized map archives. So clicking on those links will bring up your ability to see what maps they have in this collection. This is a good example of one that might be applicable for environmental research in this area of the world. A lot of online atlases now seem to be aimed at sort of K through 12 education. So there's lots of examples out there where you can load atlases that can be incorporated into K through 12 education assignments, or just if you're a nerd like me and want to make sure your child has a good geography background, you can do that for fun at home. This is a really cool example of an analytical map. This is called Orbis, the Stanford Geospatial Network Model of the Roman world. This is a really complex project of research in the humanities, and I've pulled up an example here where if I have the ability to do all sorts of things through this online application. I can say that I want to calculate the historical route from Constantinopolis to Roma, so Istanbul to Rome. I want to choose what season of the year I'm going to be departing in. I want to say I want the fastest route, the cheapest route, the shortest route. What avenues could I potentially take to get there? So road, river, sea, and how am I traveling? And then I can click calculate route, and it'll tell me based on those parameters. It's accessing GIS data that is on the back end, and it draws this line here that shows me what my route would be. It gives me a description that the fastest journey in July would take 20 days, covering 2,600 kilometers. And then this interactive box pops up where I can click on different elements of the journey and learn more information about what I might be experiencing if I were making this journey in the past. So this is maybe a more complex example, but I think a really nice illustration of just how much can potentially be done with and can potentially be communicated to people interested in this topic, give them a chance to explore it further on their own, and potentially incorporate this as a tool into formulating their own research questions. I'm sure this is an example that we'll all recognize, an animated Doppler radar map. This is from AccuWeather.com, but an example of using animations in an online web map. This is an example. How many people know about this? It's called OGO, and it's maintained by the Ohio Department of Transportation. Has anybody ever used this before? This is actually an online application that you can find out real-time updates about delays that might be happening. If you have to travel across the state, like I did this morning, you might want to check this and see what sort of construction is happening, what kind of delays you might encounter. It updates in real time as you pan and zoom around the map. So this was yesterday. I could see that there was an accident on I-75 at one of those locations, and another alert at one of the rest areas. So an example of something that you could look at on a mobile device or in the web and get up-to-date real-time information, in this case about traffic alerts, but there are others, weather, things like that. And then this is a really popular example of a collaborative effort. This is me zooming into the University of Cincinnati campus, and this is the look of OpenStreetMap. OpenStreetMap is this collaborative effort where individuals around the world are essentially going in and creating points, polygons, lines, vector data of their areas, and this can be updated periodically as new buildings are constructed, as new roads are constructed, but this is all sort of being done by different individuals around the world. You can sign up yourself if you want to edit or validate any of the features that others have created in this map. I heard that there's potentially a new soccer stadium that's going to be constructed, so somebody can go in and put that in there. That's a hot button issue, yeah. That's what you can do. There's some other sort of examples where you might have ideas for, say, at a municipal level, the local government has ideas about how, let's just use the soccer stadium as an example, like how the transportation could be affected, what new roads might need to be built in the area to allow people to get to and from the stadium, and then to put a web map up online and enable comments so that somebody could go in and click on a point on the map and say, well, I have concerns about this, or this makes a lot of sense to me, or how's this going to affect people in my neighborhood, and gather information from your community that way to make better decisions about transportation policy and over the longer term. So those are just a few examples of some types of web maps. Elements of web maps generally can be broken down into sort of three different major categories. The first one are base maps, which are not the focus of the map, but they help to provide geographic context for whatever is the focus of your map. The thematic layers are really what the focus of the map is, so creating geographic features that represent some sort of theme or data set that is important to you and you want your viewers to learn more about. And then interactive elements, so things like sidebars where people can select specific maps that they want to take a closer look at, or if I click on a feature on the map, a bar chart comes up, a pop-up comes up that provides me more information or more data. So this is an example of a base map. This is just an image online of the OpenStreetMap base map for the city of Melbourne, Australia. And one of the things that has really revolutionized the way that web maps have been created was this idea of tiled mapping. So caching tiled layers of geographic information so that every time somebody pans or zooms in the map, everything doesn't have to reload anew. So what this means is that base maps and even other types of features, but really this is most commonly applied to base maps, are broken up into these gridded sets of tiles at a variety of different zoom levels. So to cover the entirety of the world down to basically the building level, there are about 20 different zoom levels. And every time someone zooms in, one grid cell is turned into 4 grid cells. So this becomes a massive number of grid cells by the time that you get to the building level. What happens is these images are essentially cached so that only the images that somebody needs, depending on what zoom level they're at and what area of the map they're at, actually get called upon and displayed. So this speeds up things tremendously because you're not rewriting, reloading the data every single time. You're just loading a small subset of already cached images to display the geographic context. We'll talk a little bit more about either accessing existing tile sets or building your own tile sets a little bit later on in the presentation. This is an example of thematic layers. So this is actually from a screenshot from the Cincinnati Area Geographic Information System. If you're not familiar with this particular portal or just kind of the GIS data landscape in general, there is a very large emphasis in the GIS community from data producers and consumers on this idea of open data. Many cities, counties, federal agencies, state agencies have open data portals where you can go in and access and download geographic data, other kinds of data. So this is for the city of Cincinnati. And you can see on the right-hand side here, so I have my base map for the city of Cincinnati. And on the right-hand side, this is an interactive element. I clicked on the button to show me all the different layers that I could display in the map. And I just picked a couple. So I chose the survey monuments. And if I click on a particular entry within survey monuments, I can see what the symbol is. So all of these little black triangles are survey identification monuments around the city of Cincinnati. And the other one I chose was Cincinnati Historic Landmarks on the National Registry. So all of these different brown polygons are areas throughout the city that are categorized as historic landmarks on the National Registry. So I can toggle these things on and off. It'll update dynamically as I pan and zoom around the map to show me new survey monuments, new areas that are on the historic registry. But that's the idea of thematic layers, that each one of them kind of is one type of data that you batch together as a thematic layer and allow people to see on the map. Excuse me. And then the last element is just interactive elements. So this is a screenshot from a web mapping API leaflet that we'll talk a little bit about later, but you get the idea here that if I click on this blue marker, a pop-up comes up, and in this case it's telling me that it's a pop-up. If I click on the red circle, it tells me a circle, but you can configure those pop-ups to have whatever information that you would want. You may have noticed this sort of thing if you regularly use like Google Maps. You can see people post their photos on Google Maps. You can click on a restaurant and see reviews, that sort of stuff. So all of those things are interactive elements that can be incorporated into a web map. I'll leave some time at the end for questions, but does anybody have any questions now before we get going into sort of different approaches to web mapping? Okay. So I have broken down the idea of web mapping into two really kind of broad approaches that I've just called data plus development and data plus template. And I'm going to talk a little bit more about both of these as we go. Data plus development is definitely the more complex approach. There are some advantages and there are some disadvantages to it. And data plus template is a lower barrier approach for novice users. It's what we're actually going to be doing later today in the workshop, and I'll tell you a little bit about some tools that can be used for that. This discussion of web mapping is by no means comprehensive, nor are the lists of tools that I'm giving you, but if you decide that you want to explore this topic more, we're gonna talk about data plus development first. But if you decide you want to explore this topic more, there's a really great online course. It's an open educational resource, so everything, course lessons, course content is accessible. It's called Open Web Mapping. It's by Dr. Sterling Quinn at Penn State University. So there's lots of really good information there that can give you some more details about web mapping considerations and workflows for doing that. In both cases, it starts with the data. I mean, it starts with your research question. It starts with what data you have or will need to create or access. You're always going to have considerations, and so you're going to need some level of skill in locating or creating GIS data, understanding GIS data formats, organizing it, standardizing it, managing it for input into whatever web mapping environment you're going to use. And then it's just a matter of, do you use a pre-made template, or are you going to sort of build something from the ground up? So if you're going to build something from the ground up, this is just a look at what the system architecture to do that looks like. And we're going to walk through each of these components so I can give you a little bit more context about what happens at that level, what are some tools that you might be able to use at that level. So the first level in the red circle there is the administrator or internal client applications. Some of you have already used this. This just sort of refers to desktop workstations that you might have to prepare data, to create map features, map layers, to manage access to those things within your organization. Some examples of programs that you can use to do that are ArcGIS. It's sort of the industry standard GIS software. The little P in parentheses there means proprietary. So you'll get an understanding of what open source options might be available versus proprietary options. And then another one is Quantum GIS or QGIS. The FOSS stands for free and open source software. So that is something that can be used to carry out many of the same functions that you can do in ArcGIS, but you can do it across different platforms. ArcGIS is just a Windows desktop application, and you can customize it if you know Python. You can create your own tools. The second tier, which is the file server and database server there, is called the data tier. This is where you would store your GIS data. You can take a couple of different approaches to storing the data. You can take a file-based approach versus a database approach. Common file types that you might encounter if you are working with geographic data are shape files. Originally started as an Esri ArcGIS proprietary format. Now it is an open format. A lot of GIS data on the web is made available as shape files. KML you might recognize if you have used Google Earth. It was originally a proprietary format for Google Earth, now also an open format. So the fact that some of these really popular GIS data formats have gone from proprietary formats to open formats really kind of opened up possibilities for people to use open source tools to advance their work using data that they previously might not have been able to access or work with because it was in a proprietary format. And then GeoJSON is a form of JSON or JavaScript object notation, which is kind of a way of, in a text-based format, storing information about vector data. I don't have an example of what that looks like, but GeoJSON is a really common way of storing vector data and working with certain web mapping APIs like Leaflet, which we'll talk a little bit about later. If you have a relatively small amount of data, or you have data that will not be updated very often, then a file-based approach is potentially a cheaper and more efficient way of doing things. If you have a lot of data, if you have data that is updated regularly, or if you have data that you need to link. So I have a table that tells me what the population of every state is, and then I have a GIS data set that is the boundaries for all of those states. And when somebody clicks on that state in the map, it needs to pull information from the table to tell me what the population is. Then you're going to want to use a relational database approach. Proprietary format for that kind of storage is the Esri file geodatabase. It's a really common format now that's used with ArcGIS, but there are some open source options for storing geographic data in relational database forms. PostGIS, which is an extension of PostgreSQL, if anyone has heard of that as a relational database management system. And then another one called Spatial Light. So those are some options that you could use. And the reason that I'm including this information about open source is because this is a complex way of doing things, but I want to emphasize that there are tools out there that give just about anybody the ability to do this themselves. Because depending on what your needs are, you don't necessarily need to have separate machines for all of these components. You can download these tools onto your own machine, a single machine. You can create all of the different elements that you would need to develop and serve a web map, and you can do it essentially for free with many of the tools that are out there. The next level is what's called the geospatial server. So this is a little bit different than the data storage server. This is really kind of a hosting environment and specialized processing power environment, so that as your GIS data are being queried, you can serve them up to do specific things. You can either render them so they display in the map. You can give people the ability to query the layers, like I was doing with the Cincinnati Area Geographic Information System, where when I click a box, it sends a query back to the server and pulls up the locations of those features, the survey monument features. Or you can allow it to perform GIS analyses. So the same way we saw with the network analysis in the Roman world example, that as I chose to do things within that application, it did the analyses and it returned the results. Some options for this are ArcGIS Enterprise. So a component of ArcGIS Enterprise is known as ArcGIS Server. That's a proprietary format. And then there are a couple of open source options too, GeoServer and MapServer. Then we have the web server, which is the network entry point. So the area where you can store application code that for things like the interactive elements, for the organization and design of the website, you could store on the web server, and then it gives clients an entry point to come in and start to work with the application, where the other underlying elements, the file server, database server, the geospatial server, respond based on what the client chooses to do or the end user chooses to do. And some examples of this are Apache, which is open source, and Microsoft ISS, which is proprietary. One of the nice things about GeoServer, which I talked about on the last slide, is that if you want to do something like this and you need to preview it from an end user perspective and make changes, there's a component of GeoServer that basically functions as a web server for your local machine. So you can make changes, you can preview them, you can go back, you can make other changes. You would need a full-fledged web server when you wanted to expose it to end users, but you can use GeoServer to at least make some of the initial changes based on your previews. Two other things about this approach to address are the fact that one of the types of data that you might choose to store in your data tier would be tiled base maps. Tiled base maps, I'm not going to get into it because it's pretty complex, but you have to have quite a bit of expertise to generate a really good, accurate tiled base map. So thankfully, there are lots of existing ways that you can access tiled base maps that other people have produced and make available through their application programming interfaces, their API. So You can use, and then each of these have different policies, so if this is something you were going to do, you would want to make sure that you had accurate information about the terms of use, but OpenStreetMap makes their tiles available for usage in applications that you might be developing. Mapbox, Carto, Google, and Esri, which is the company that created ArcGIS, all have versions of tiled base maps that you can use in your applications through their APIs. If you decide that you would want to build and serve your own map tiles to have an even more customized experience, there are a few different ways to do that. GeoWebCache and TileMill are open source softwares for doing that, and then Mapbox Studio is proprietary in the sense that its source code is not available, but there are ways that you can do things for free. You can pay per use of certain elements of their site. So if you have low traffic web maps, then you will probably be doing stuff for free. If you're managing a high traffic web application, then you're going to start to pay per use. But this is an area that's worth exploring further if you decide that this might be a route you want to go, because there are both raster-based options and vector-based options for creating tiles. And then the last part is sort of how you bring all of these things together through web mapping APIs. This is basically the framework for creating your front end. So all of this stuff is happening behind the scenes on what we would call the back end of this application, but the web mapping API is what you use to create your front end, to organize everything, to give your end user access to the types of data and functionality that you want to include in your web map. One of the most common web mapping APIs is called Leaflet. It's free and open source. It's a JavaScript library that allows for sort of bringing all these elements together, creating interactivity for your application. Open Layers and D3, or data-driven documents, are also both free and open source. They're JavaScript libraries as well. And then Google Maps and ArcGIS also have JavaScript APIs, but in this case you're actually accessing their proprietary content. So you're using the Google Maps API to access their tile-based maps, or ArcGIS API for accessing tile-based maps or customizing ArcGIS content for your web application. So if you're a developer, you can get access to all of these different things and start exploring on your own. So what are some of the things to think about for this approach? The major advantage of this approach is that it's extremely customizable. You can do virtually anything to create the desired user experience for your application. This obviously requires a fairly substantial amount of expertise in terms of both GIS data and in terms of web development. So from the GIS data side, you're thinking about things like creation, formatting, organization, data management. From the web development side, you're looking at having some experience with probably these three programming languages. HTML, which is primarily for web content organization and delivery, so creating the structure of your website and managing the content. CSS for styling the website, and then JavaScript for creating the interactive experience for your user. For this reason, I think most, if not all, web mapping projects tend to be fairly highly collaborative. You're not going to necessarily find somebody that has skill sets in all of these things. That's not to say it doesn't exist. Many people probably do have the skills to do this, but in many cases, depending on the discipline, depending on the area of research, you might be bringing in somebody who's a GIS specialist like me to help with the first line there. You might be hiring a developer or working with a developer to actually create the structure and experience for your users, and you're the content expert. You're the subject expert who is saying, this is the information that I want my users to be able to explore, this is what I want to communicate to them for my research, and this is the experience that I want them to have, and that's a team that works together to make that happen. So this means that there are potentially costs associated with this sort of approach. You might need to apply for funding to pay for development time. You have to think about infrastructure for long-term hosting, maintenance, preservation of this application if you want it to live over the long term and not stop working when there are web technology changes that happen, new browsers, new formats, those sorts of things, and then also potentially software and hardware needs. So there are a lot of open source options out there, but depending on the complexity, you might need to set up an infrastructure where each of those different components is on its own machine, and you have to be able to pay for that infrastructure. The other approach is much less complex and is what we're going to be doing later today. And this really focuses on the idea of inputting your data into a variety of sort of builder modes or templates that exist for various online mapping platforms. I'm only going to talk about 3 of them today: Google Tools, Carto, and ArcGIS Online and its story maps component, and give you a sense of what these are, what's possible with them. So as far as Google Tools go, and these are all, they're all free options available for these tools if you want to explore them more on your own. As far as Google Tools go, there are a couple of different components. There's something called Google Fusion Tables, where you can basically upload a CSV file of geographic locations and associated information, and it will spit out a map. It's very limited in terms of its customizability. All the points are going to look exactly the same. People are going to be able to pan and zoom and click on the points, but not a whole lot more than that. There's another Google tool called My Maps, which you can use to input geographic information, do some styling of the symbols. Someone can click on a symbol and see a pop-up. I actually used Google My Maps. So when my wife and I got married, we created a website for all of our out-of-town guests, and I created a Google My Maps to show them where the hotels were, where the wedding venue was, and I embedded it into a website. And so I wouldn't consider myself a good GIS specialist if I hadn't done that. It's totally unnecessary, but for me it was a requirement. So they could click on the hotel and see information about it, call to make reservations, that kind of stuff. And then the last one, and this is a screenshot from the last one, is called Google Tour Builder. It's in beta right now. It uses the Google API to call in a base map and allow you to add geographic features, allow you to add sort of points along that tour with other content. This is very similar to the kind of thing we're going to do today with ArcGIS story maps, but this is an example from the Jane Goodall Institute, where as you click around the map or as you move your way down the different points on the left-hand side, you're going to see a new photo, you're going to see a description of what is significant about that point. So these are kind of a nice way of using pre-built templates to combine different types of content. Geographic content, multimedia content, text, photos, videos, etc. This is Carto, which I don't want to say is like the new kid on the block, because it's been around for quite some time in various formats, but it's really sort of the emerging online mapping platform. It's marketed as sort of this drag and drop location intelligence tool, and there are free versions available for students, educators, and researchers if you would like to pursue learning this. It creates really nice interactive maps that, if you know a little bit of programming, you can customize, you can embed in websites. This is an example that was embedded in a site called thisisnetneutrality.org, where you can see sort of the net neutrality status of countries all across the world, and you can click and get a pop-up that describes sort of recent developments in that arena for each of the different countries. And then this is a screenshot from a template associated with ArcGIS Online Story Maps. So ArcGIS Online and Story Maps are proprietary Esri tools. They have really nice connectivity in terms of moving data back and forth between the desktop version and the online version of the software. So I might do a lot of data preparation in the desktop and then publish it to my online account to create a web map. There are also free public accounts. There are some limitations. If you have a free public account, you can't really do any of the hardcore analysis, and you have some storage limitations, but for a lot of purposes, the public account could work. The other thing you can't do is upload your own images. You have to completely be linking to images that are on the web. So if you maintain a website, you can upload your images to that, create links for them, and then you link to them with your story map. So this is a screenshot from a map called The American Experience in 737 Novels, where each of these, you can click on each of these and see a picture of the cover. You can see the title, more information about the novel. This is information about where in the United States those novels are set. And as you zoom in, the circles get smaller and smaller, and you see more and more of them, and you can eventually click on individual points that correspond to these novels. This is created using a template called the crowdsource template. So although this was done by an individual without crowdsourcing the information, this is a template where you can actually say, well, I want people to tell me, there's an example where it's called National Park Memories, and it's basically enabled so that as people go to the national parks, they can take a photo, they can upload that photo, a short description of who they are, what their experience was in the park, and it gets added to the map so we can see what the tourist landscape of American national parks looks like. So some considerations for this approach. The big advantage is it really is a lower barrier to entry for beginning users. You might not want to pay for or learn everything you need to know about the development approach, but you think the product that you'll get with the template is pretty good and useful for your purposes. Another advantage is it doesn't require local hosting of the data. When you create feature layers, you're basically uploading data into the cloud storage for each of these different applications, so you don't have to worry as much about that, but you do have to be cognizant of what data you can actually share into a cloud environment. The limitation is that it's for the most part limited to built-in capabilities of the template. So there are some examples where you can do some customization, you could download the templates and do some additional development depending on your needs, but it's not going to be as customized as what you would create using the other approach. I have a citation down here that I would encourage you. This is a recent article from last fall by a couple of librarians, I think at the University of Georgia, called We Mapped It So You Don't Have To, Comparing Online Data Mapping Platforms. So they compare, they take sort of a research project scenario and compare the workflow in Google Fusion Tables, ArcGIS Desktop, and ArcGIS Online, Carto, and another platform called Neatline. And they talk a little bit about the pros and cons of each of those, what the end product looked like, and so researchers can kind of think a little bit about how they might want to apply it themselves. So I would encourage you to check that out in College and Research Libraries News. So just to kind of wrap up, the last slide I have here is just kind of a breakdown of what I consider to be some of the advantages and maybe considerations to think about if you are going to be working to develop a web map. So on the advantage side of things, as we kind of saw throughout, there are a lot of free and open source options. So a lot of ability for experimentation without having to invest a lot in terms of cost for software. A nice thing about web maps that differs from desktop applications is that, you know, generally these things are going to work across browsers, they're going to work across operating systems, whereas that might not necessarily be true for the sort of more advanced desktop applications like ArcGIS, I said, is only a Windows platform. You can combine data from a lot of different sources. You don't necessarily have to host everything yourself. You can host your own data, but if other data are available as web services, you can pull them into your map and display them. You have a lot of ability for personalization and customization depending on what your needs are and what you want your user experience to be. This has really enabled collaborative projects to be carried out, user communities to develop, especially around some of these open source tools. There are large communities of individuals who are actively developing these tools and improving them for the rest of us to use. And then you can link to and integrate other content with your maps. So we saw the example of the images. When we do the workshop today, we're going to look at how we can integrate photos. We're going to look at embedding audio clips. We're going to look at embedding hyperlinks to other parts of the web. So these are things that are really easily done in a web mapping framework. Considerations to think about, bandwidth issues. So in a desktop environment, it's sometimes customary to want to be looking at many different data sets at one time, where each data set is its own layer, and as a user I just toggle on and off the data sets that I want to look at any given time. In a web mapping environment, this is going to potentially create bandwidth issues. It's going to slow your application down, and sort of in today's era of the web, if something doesn't load in 2 or 3 seconds, we're immediately giving it a bad review on some social media site. So that's something that you want to think about. The other thing that often kind of gets missed in that conversation is the fact that if your web application is super popular and thousands of people are using it concurrently, that creates issues too. So not only on the front, on the side where you're actually inputting the data can create bandwidth issues, but how many people are using it at the same time can create bandwidth issues and cause you to have to think about, those hardware and software requirements moving forward. Limited screen space, especially for mobile applications. So I'm sure that we've all probably at some point in time encountered a map on a piece of paper that would stretch across the entirety of one of these tables, and we could walk up and down it and see the information that we wanted. That's not true for web maps. You have limited screen space. Sometimes on your phone, you're looking at very tiny features, so something to think about as far as the aesthetic experience, the user experience. Data quality and accuracy issues. So on the left-hand side, the advantage is you have the ability to combine data from many sources. On the right-hand side, you definitely, if you're going to do that, want to make sure that you're doing your due diligence to check the metadata, to understand the source of that data, to understand any limitations that might exist for using it in your own work, so that you're not utilizing inaccurate or unreliable data sets. They can be complex to develop. I think we've seen that from sort of the system architecture. Permissions and copyright issues. So if you are using tiled maps from OpenStreetMap, they have a terms of use policy. You want to make sure you are following that so you don't run into any issues. If you are incorporating multimedia content into your maps, you don't want to use copyrighted photos potentially. You can make an argument that you're using it, that it's fair use, but for the most part, if you can find Creative Commons images or content that will serve your purposes, then great, you can use that. Otherwise, you need to make sure to keep that in mind. And then the last one I just want to quickly touch on is privacy issues. So as more and more information gets mapped and becomes available to be mapped, 2, 3, 4 pieces of information, we might be able to be getting down to the individual level. We might be seeing that based on somebody's level of income and their occupation and their race, you might be able to identify who that individual is as a point on a map. And that, depending on sort of the sensitivity of your research, is something that definitely needs to be considered as you're creating these applications and distributing of that information. And with that, I'm going to just turn it over to the big question mark. And what questions do you have for me? Yeah.
When you upload data to the ArcGIS cloud or whatever, can you use that cloud and embed it into a different website? Like, can we have our own website and connect it to the ArcGIS cloud and use them as the map server?
So you can do either of those things. So if content is available elsewhere on the web as a web service, there's an option for importing that web service into your web map and then using it. Or you can create your own layers based on content that you're uploading to ArcGIS Online. There are a variety of different formats that you can upload. And so you've uploaded your data, you've created a feature layer with that data, it's displaying in your map, and you can either share the link directly so somebody gets only to that map, or depending on what sort of content management system you're using, you can embed that into an iframe in the website. The thing that you need to do if you want to have that be accessible is ensure that in ArcGIS Online, you've selected that you want that to be public. So the default when you upload data to ArcGIS Online is locked. It's just open to you. At Cincinnati, you have an organizational account for ArcGIS Online, so if you want to just share it with other people at Cincinnati, you can say share with my organization. If you want it to be completely accessible, you can say share with the public. And then if you share with the public, every layer that that data set is connected to needs to be shared with the public. And if you don't do that and you try to share something at a higher level, you'll get a warning that says you need to share this level too if you really want your users to be able to access it. Other questions? So does anybody sort of have ideas? Kind of the wheels are turning a little bit about how you might use this for your own work. I think hopefully if you don't quite know right now, hopefully the hands-on part will get you thinking about that a little bit more. I'm hopeful that you'll see sort of how easy it is to build a story map with ArcGIS Online and think about how you might incorporate your own content. Any other questions? And I'm here for the rest of the day. My contact information is on the handout. So like I said, if nothing's coming to you now, but you think of a question over lunch or at the end of the workshop, let me know. Or if you want to contact me later, feel free to reach out to me by email. All right, thanks.